Dear colleagues, welcome to our dialogue, to our monthly webinar. As you know very well, these are Socratic dialogues among editors, authors, reviewers, readers, and we invite top scientists to these to our dialogues. Top scientists who share with us not only their scientific experience, their remarkable scientific experience, but also their human experience. And today it is my privilege to ask Professor Peter Libby, who is Executive Editor of the European Heart Journal. By the way, today is Thanksgiving in the States, so thank you, Peter, for renouncing at least transiently to Thanksgiving to stay with us for this dialogue today. So it's my privilege to ask Peter to start the dialogue with an important colleague, Göran Hanssen. And the title of this dialogue is The History of Atherosclerosis, narrated by a protagonist. And Göran Hanssen has been a protagonist of the history, is a protagonist of the history of atherosclerosis. But today will be with us with two hats. One is a top scientist in atherosclerosis, but also is an important member of the Nobel Prize organization. And we are very curious about this incredible organization, which every year bring us new champions in science. Peter, please, can you introduce Göran, and we'll start our dialogue.
Sure. So, Göran, good afternoon. Thanks for joining us.
Hi, Peter.
You grew up in Western Sweden, I think to the north of Gothenburg. And if I remember correctly, your dad was a journalist, so you sort of were born with ink in your veins. Does my memory serve me correctly?
That's absolutely right.
Yeah, and I guess you started piano lessons early on, right?
So I did, yes. I was lucky to have a wonderful teacher who was teaching at the conservatory in Stockholm, who spent her vacations in Lysekil, in a small town where I grew up. So I learned from her.
And so it was natural for you to go to Gothenburg University, where you did your MD PhD, and you were in Göran Bonder's group for your PhD. And so that was a time when atherosclerosis research was very greasy, and I'll ask you to elaborate on that in a moment. And then you migrated west to the Temple of the Lump, where people were very interested in smooth muscle cells. You worked in Steve Schwartz's laboratory, which is where I met you. And that's where Russell Ross reigned supreme with his interest in smooth muscle cell proliferation and platelet-derived growth factor. And those were interesting times. As I recall, Steve Schwartz had a habit of midnight calls, and that Steve and Russ didn't always get along well. So that was a fun time. You have any interesting memories of Seattle, and maybe you could explain about the grease and the lump?
Yes, yeah. I gave a talk at one time when I came back to Seattle after the postdoc, and I tried to, before I went into my own work, I tried to summarize the prevailing theories about atherosclerosis. So I called the talk Grease, Lump, or Wound. And grease, of course, was the cholesterol accumulation. Lump was Earl Bendit's idea that atherosclerosis was really like a tumor formed by smooth muscle cells, like a myoma. And then wound was the response to injury hypothesis of Russell Ross. Yeah.
But then,
and of course, this was a wonderful time. It was Seattle was very strong in vascular biology and cardiovascular research, and it was in a way stimulated, prompted by the tension between Russell Ross and Steve Schwartz and Earl Bendit. The three of them had different opinions about most things, and everybody was competing with everyone. And at the same time, the doors were open and they were stimulating seminars and discussions. So a combination of competition and and scientific discussion, kind of friendly rivalry. It was good to be a postdoc there. It was very stimulating.
And so you would use the tools of immunology even in your PhD, if I recall correctly. But then you established your own laboratory at Sahlgrenska Hospital back in Gothenburg, and you changed directions. And you went from Greece to lump, and maybe the wound was a good transition to the fire. And so, what got you interested in inflammation and the immune response in atherosclerosis, and how did that all start?
That started already when I was doing my PhD. I took a course in immunology, and I fell in love with the subject. And then I thought that, very simple-minded thought, that the atherosclerotic lesion and blood vessels are next door to the immune system with all their powerful signaling molecules and cells. So I thought the immune system got to recognize somehow this pathology building up next door. And therefore I did, in my PhD thesis, part of it was identifying, localizing antibodies and complement factors in atherosclerotic lesions. Then later on, then in Seattle, I worked on endothelium and smooth muscle cells. When I came back, I decided to look into the human atherosclerotic plaque with the monoclonal antibodies that had just become available, new fantastic tools that could identify cell types very specifically, as you recall. And I thought, let's use these antibodies to make a map of the cells in the atherosclerotic lesion. And of course, we find the expected things, endothelium, smooth muscle cells. We found macrophages, that was also predicted by several investigators. And then we found signs of activation on the macrophages, HLA molecules that they start to express when they're activated. So something must be activating them. And what could activate the macrophage? The obvious candidate was the T cell that makes interferon gamma that induces activation. So we looked for T cells, we found it. We looked for interferon gamma, we found it. And that told us that this is not only passengers, these are active players in the disease process. And we published that in the mid-80s, 2 papers. And the general response was that this is probably not correct. And if it's correct, it's not interesting. But the tide changed, and you and I were among the few who were thinking along these lines. I remember when we tried to publish our first review paper on, I don't remember if it was called inflammation in atherosclerosis or the immune system in atherosclerosis, but the prestigious journals turned it down because they said the topic was uninteresting. But we got it into one journal at least, and since then we've written many reviews in different journals to try to identify the major challenges in the field.
So, as I recall, Lena Jonasson, was she your first PhD student? And so, a laboratory in those key experiments, those original 1985-86 papers, Lena was an integral part. So, your role in training, and particularly so many women have been through your laboratory who've been successful. Has training been a satisfaction for you? And what tips do you have for people on how to cultivate the careers of the next generation?
Well, I think I've been lucky. I've had bright, highly motivated students joining the lab. Lena was the first, and there have been several others, many others. And when you have that kind of people, it's not hard. You have to, I think it's important to maintain an enthusiastic approach, not be bogged down into the competition and into technical details, but maintain a perspective on what the problem is that we're trying to solve and the privilege we have working in science, and not least the enthusiasm. I don't know if you've seen Carlos Kleiber conduct an orchestra. There are some great clips of it on YouTube, and he was considered the greatest conductor of the last decades. And you can see the enthusiasm he conveys to the members of the orchestra. I think if you can convey just a little bit of that, it means a lot to the fellows.
That's great. So you did discover T cells and activation of T cells. You had an interest in gamma interferon, but you've made so many different contributions, including the importance of B cells, the concept of vaccination. What do you consider actually your peak scientific contribution if you had to choose?
Well, if I have to choose, it has to be that first discovery, because it set the scene for so much else. I've been sort of following up ever since. We were extremely lucky to, and we had a good idea, admittedly, to think that it was worthwhile looking at not only at macrophages, but at macrophage activation in the human plaque, get the reagents that made it possible to do, and then finding them there, finding that opened up the whole story. So I think that was probably the most important contribution. And then we've been lucky to follow it up and adding piece after piece to the puzzle together with you and many other investigators.
Yes, now it's become a crowded field, but in the beginning it was pretty lonely. So I know that Filippo wants to ask you some questions about your special relationship with the Nobel organization, actually from two different vantage points. So Filippo?
Well, thank you, Göran, for your question, initial answers. And now let's move to another passion in your life. I'm sure that you have many passions, including music, but I believe that the second passion in your life is the Nobel Prize. You have a unique perspective, as you have been vice chairman of the board of directors of the Nobel Foundation, and also chairman for many years of the Nobel Committee for Physiology and Medicine. So this perspective is really, really unique. Can you tell us about the origin of the Nobel Prize? The history of the Nobel Prize is fascinating. I think that some colleagues in the audience know about, but perhaps the majority doesn't know this incredible history which brought to the Nobel Prize. Can you please summarize it for us?
Sure. First of all, Filippo, thank you for having me. It's really a great privilege to be on this dialogue series. Well, let's start from the beginning then. Alfred Nobel, as I think you all know, was an inventor who invented dynamite and made lots of money from it, because this was in the 19th century when the cities were rebuilt and the railways were built across Europe and North America. And fortunately for us, he didn't have any children. So he, in his last will, he decided that his estate, his money should go into a fund that would be used to award prizes every year for those who have made the most important discoveries in physics, chemistry, medicine, most important contribution in literature, and to peace work. So that's how, and then he identified the organizations that were instructed to identify the prize winners. And since then, and that's his family, his nephews were not happy with it. So there were some legal problems before they could start. But in 1901, 5 years after Nobel's death, the first Nobel Prizes were awarded. And they were quite large for the time. Very important prizes also monetarily, so to say, which mattered. They were international at a time when, you know, the president of Italy awarded Italian scientists and authors, and the King of Sweden awarded Swedish ones. It was truly international from the start. And his Nobel stipulated in his will that no consideration should be given to nationality or ethnicity. And then the first decades of Nobel Prizes were at the time when our view of the world changed completely, thanks to the breakthroughs in physics. So if you read the first Nobel Prizes in physics in the 1910s, 20s, you have Curie, Planck, Einstein, Bohr, Schrödinger, Heisenberg, Dirac, and so on, the people who changed our view of the world and made outstanding contributions. So that sort of set the level of the Nobel Prize. And I think, and then you had, a few decades later, you had the molecular revolution with awards to Watson and Crick and Sanger and Jacob and Monod and so forth, Brenner, of course. So today, I'd say that the legacy is the most important asset of the Nobel Prize. It's not the sum of money, it's the legacy, it's the awards that have been made. And of course, that puts an enormous pressure on us who are involved in choosing Nobel laureates today, that we have to keep the standards and we have to make sure that what is nominated and proposed is truly an important discovery. And that's one of the reasons we are rather slow sometimes.
Thank you, Göran, for this historical perspective. Let's come now more to your personal experience. Which circumstances brought you to become chairman of the committee?
I moved from Gothenburg to the chair of cardiovascular research at the Karolinska Institute in 1995. And a couple of years later, I was elected to the Nobel Assembly, a body of 50 members who elect the committee and who makes the final decision on the Nobel Prize. And from there on, I was elected to the committee a year later as an adjunct member. And I guess I didn't misbehave too much. So some years later, I was elected chair, and I was chairman for 3 years. Then I became secretary of the committee, which means that I was involved also in a coordinating function vis-a-vis the Nobel Foundation that handles the funds and so on. So I started serving on the board of the Nobel Foundation in 2009 and was on there for 12 years or something like that.
Thank you, Göran. I remind our audience that our dialogues are very interactive. So please ask questions. You can ask via chat, or you can raise your hand and you can ask the question in person. Göran, we already have a burning question coming from a colleague, which who perhaps you know, I'm not sure, but she works in Sweden and she works in Stockholm, and her name is Cecilia Linde. She's executive editor of the European Heart Journal. And I've read her question. It's a burning question, but Cecilia, please ask the question personally.
Hello, Göran. Nice to see you. You know, we've been talking about this before. I know that you are very eager to describe the extensive process which is involved in finding nominees for the Nobel Prize. So that's my first question.
Sure. Hi, Cecilia. It's good to see you. We often meet in real life, but now it's over the screen. Yes, we feel very strongly that this is an international prize. So every year we invite people all over the world to nominate. It's of course Nobel laureates, but it's also members of academies all over the world. We write to the deans of medical schools asking them to send out forms for nomination to faculty members, and we do it in a rotating scheme. So it can be, so say, Rome 1 year and Milano the next, Tokyo 1 year, Kyoto the next, and so forth all over the world. So over, say, 10 to 20 year time, we've covered, I think, all institutions with medical research over the world. And if you never get invitations to nominate, you should contact the dean of your medical school and ask him or her why they don't send out these invitations that they get, because we don't want invitations from institutions. We want from individual scientists, and they should be distributed to the full professors at the universities. So with that system, we want more, but we get around 500 nominations for each prize each year, and go through each one of them in the committee. Identify a shortlist, of course, and then we evaluate the candidates on the shortlist very carefully in-house, and then ask experts around the world to help us evaluating the importance of the discovery, who made the key discovery here. It may not be the person who gives the plenary lectures or writes the review articles in the top journals and so on. And then, of course, we have to weigh the cases against each other. We try to look into the labs in various ways I won't elaborate on to figure out who were involved there. It may not have been only the household name, but the postdoc who came with a great idea and did most of the work and so on. So we work hard to identify the key people. And then we come back with all these evaluations after summer every year. We get the nominations in February. After summer, we go through everything and usually find that either this needs another round of evaluation, so we have to work on it for another year, or we can summarize that this is good, very good, but not of Nobel class. But a few are kept, of which we know enough, and we're ready to take a decision. And then we have to weigh them against each other. It's awfully hard. Should we give the Nobel Prize to, if I go back in time, to a basic discovery such as RNA interference, RNA-mediated gene regulation, or to a clinical discovery such as Helicobacter pylori causing peptic ulcers? And of course, we have to cover both basic science and clinical medicine. We do our best, and there's debate every year, and there's always people who feel that we awarded the wrong topic or the wrong individuals, but that means that there is a lot of interest in the Nobel Prize all over the world.
Thank you, Göran. Cecilia, satisfied? Other questions?
Yes, a very short one. You will know what it is. Is it possible for more women to be eligible for the Nobel Prize? How do you ensure that? Secondly, it may seem that it's easier to get the Nobel Prize if you're located in the United States.
Yeah, with regard to female scientists, we have been concerned that they may be, we may miss them. We are dependent entirely on nominations. So we have written to nominators asking them to take a broad perspective with regard to gender as well as ethnicity. And we've commented, I commented in the public debate repeatedly about the need to get nominations that are not gender biased. So we asked our nominators to think about it. And we also educated ourselves. We've had conferences with gender experts in sociology, for instance, and we made sure that there is representation of both males and females on each of the Nobel committees. It's in a way easier in medicine. It's not perfect in medicine, but if you take an area like physics, I think of the world's physicists, between 5 and 10% are women. So it's going to take a very long time before we have 50% physics Nobel Prizes to women. But we mustn't overlook those who are out there and who are worthy of the Nobel Prize. And you can see that we've had 2 women in the last 5 years winning the Nobel Prize in physics. So that's a good sign, and even more in chemistry.
Thank you, Göran. Another personal question. In this activity, what has been the most rewarding moment, the most difficult moment in your activity in relation to the Nobel Prize?
Well, the most rewarding is making the phone call. I think I called 53 Nobel laureates and 14 economics prize laureates over the years, so 67 calls. Some are astounded and surprised, and others may have been waiting for it, but they are all very happy, and that's of course extremely. It's fun. It's great. It's great to have a job, the job to make people happy. Then of course there are all those who are disappointed when the prize is awarded, but I haven't been exposed too much to that, so it's been mainly a very positive experience. The toughest is the decision. The discussions are of very high quality, I must say. Everybody races above bias and lobbying, but it's a hard decision. So that's tough. It's fun, but it's challenging.
And the telephone call is the first communication, no emails or letters, just a phone call to start with. Yeah,
no.
What was the most amusing reaction you can remember?
Well, I had some problems with the Nobel laureate in chemistry in of last year, David Macmillan. I called and I started speaking, and then it was disconnected. So he switched off the phone. I tried again, and same thing happened. So then I had to contact his co-laureate, and he said that I'll help you, I'll try. So he sent an SMS to David Macmillan stating essentially that, David, we won the Nobel Prize. And he got the answer back from Macmillan, no, it's just a prank. So he sent another one, no, believe me, it's true. And Macmillan said, I bet you $1,000 that this is just a prank. And then I couldn't wait any longer, so I had to give the press conference and announce the Nobel Prize. After that, and then Macmillan got to know it. So after that, I finally got a hold of him by phone. And his comment was that, well, you guys made me lose $1,000 today, but I guess it's okay since I won the Nobel Prize.
Remarkable.
So that was kind of fun. There's a number of others. Well, another one was the economics laureates who lived next door to each other, and we couldn't get hold of one of them. So the other one said, I'll go over and knock on his door. And they both live in the Bay Area, so it means that this was 3 o'clock at night, and there is the surveillance camera outside of his house shows when Dr. Watson knocks on his door and say, wake up, it's Bob, we won the Nobel Prize.
Remarkable. Now, please ask questions because this is really a very good opportunity. I have a question from Claudia Monaco, who is Associate Editor of the European Journal. And Göran, the question is about T cells. It's about vascular single-cell biology, showing that T cells outnumber macrophages in human atherosclerotic lesions. Do you think that this is teaching us interesting new things?
It's a challenging observation. From what we see by immunohistochemistry, there are more macrophages than T cells. So which is the better analysis? I don't know. And it could also depend on the type of plaque and the stage of disease. I haven't seen all the data here, so I cannot give you a definitive answer, but I would look at the type of lesion, to what extent is fibrotic versus inflammatory, and how far it's advanced. I would want to see more data before I believe the single cell data, but I may be wrong. I've been wrong many times before.
Thank you, Göran. I see Claudia is with us now. I see her face. So perhaps, Claudia, you want to ask personally additional questions or comments? Please join us.
No, it's just a pleasure to have posed this question. I'm in the clinics today, so I'm a little bit on my phone and on the go, but yes, I think that I wanted to be provocative because I think this data from the single cell might tell us that Göran has been right all along. T cells are indeed very important, and they do form a significant amount of the CD45 life. And maybe it's a new hypothesis that we need to verify further with the immunohistochemistry. But I think it's pointing that you have been leading the way for a number of years, and they taught us everything that we know. So thank you, Göran.
Well, thank you, Claudia. It's good to see you again. The most important of this finding is that it corroborates what we've seen before. And then I would say that the numbers is not the only thing that matters. It's also the activation state, as we have both found. The type of T cell, the kind of signaling molecules it makes, how it impacts on the vessel wall, to what extent it's activated. And these cells are not just resting partners, that's for sure. They are quite active.
Thank you, Göran. And we have another question from the audience coming from Ryan Goreski. Can you please ask your question personally?
Yeah, certainly. Professor Hanssen, thank you very much for interesting and comedic talk as well. It's interesting to hear the stories of the phone calls you have to the Nobel laureates. I'm a young researcher, I'm a clinician and academic, and I'm interested in cardiac biomarkers. Now, we don't have a biomarker for plaque rupture or a biomarker for atherosclerosis, but we know a lot about T cells and inflammation and all the proteins involved in this. Why do you think we don't have a biomarker yet, and what's the way forward for that?
Well, the inflammation in the plaque is not an acute one. It's not like a pneumonia or a pyelonephritis. It's a smoldering inflammation, which means that the amount of cytokine protein produced there is rather low. And that the amount that leaks out into the circulation is even lower. So there's been very important, beautiful clinical studies, not least from Rome, that have identified cytokines that mark risk for future cardiovascular events. But you need really an amplification to pick it up. And that you get by looking at acute phase reactants. Because if you have IL-1 production in the plaque, it begets IL-6, it induces IL-6 production. Peter Libby showed that. And then the IL-6 is produced in enough amounts to go to the liver, where it induces CRP. And CRP is made in very substantial amounts. If one molecule of IL-6 induces thousands perhaps of CRP molecules. So there you have something you can measure. Not even CRP is perfect, but it's the best we have. And I think there is pretty good evidence for CRP as a biomarker of future risk. I think that's solid. But and that of course reflects plaque inflammation. So there we have a good biomarker. We don't have one for plaque rupture yet, and we don't have one for the total burden of atherosclerotic disease. So here's a challenge for you to try to find one. And we who work in the lab can come up with a bunch of candidates, and then it's your tough job to find out which are the best ones among them.
Thank you, Göran. Well, the audience today is incredibly lucky because we don't have one giant in the field of atherosclerosis, but we have two giants in the field of atherosclerosis. And the other, of course, is Peter Libby. And you have published seminal review articles in your life, which are really very well cited and very well known. So I'm curious about, and it is clear that not only you are top scientists, but we're also good friends. Can I ask you, how did this friendship start? Who is going to start?
We were very lonely in the beginning. So the session on inflammation, immunology, and atherosclerosis was usually the last session of the last day of the meeting. And there was only Göran and me and a few of our postdocs in the audience in the beginning. And so it was sort of a matter of Brownian motion that we encountered each other a lot. And then we have shared interests. Music is very important for both of us. I have a bigger foot in the 18th century. Göran has a bigger foot in the 19th century, but opera brings us together. Mm. And we've been at operas from La Scala to Sydney. And then particularly when we were younger, we used to run together in all kinds of places around the world during meetings. And we had very substantive discussions about science while running. Of course, as we got older, we had to concentrate more on breathing than on discussion. but by then we developed telepathy. And also, you know, our families grew up sort of in the same rhythm. And so we've shared a lot of personal issues as well. So the friendship began with science and began with perhaps the loneliness of being in that early age. Now the field is so crowded that there's standing room in those sessions, but in the beginning it was quite different.
Göran, your perspective?
Yeah, well, what Peter said summarizes this beautifully. I could just add that first time we met was, as Peter mentioned, when I was a postdoc in Seattle. And Peter, I think, Peter, you were about to start your lab at the New England Medical Center, and you came out to look at how vascular biology was done in Seattle. And my boss, I think, thought that someone who is as well behaved and as well dressed as Peter cannot be very interesting to talk to. So he told him, why don't you go and talk to that Swedish postdoc over in the corner? You seem to be interested in immunology, both of you, so go over there and talk to him. And we struck up a conversation, and we continued to discuss immunology and cardiology and science and culture and medicine and music and politics and everything under the sun since then, since 1982. It's been such a privilege.
I think that we can probably confess that in the 1960s, we were both rather on the progressive side. And, you know, we were on the barricades of our respective continents, I think, when we were younger. And perhaps that rebellious spirit is important in science because it spurs you to have the motivation and the courage to challenge the received notions of the day.
Yes, to challenge the authorities. Are we challenged enough, Peter? Or perhaps we are not much of authorities?
I think that it's very healthy that we have so many bright young people who are really expanding the field. And so it's even tough to keep up with. And I think that's the way it should be. I see Carlo has his hand up, Filippo.
Yeah, well, yes, I'm noting how important is jogging in the life of scientists. Actually, we have recently published an interesting paper in the European Journal showing that it is enough to jog 15 minutes per week to already have a signal in terms of reduction of cardiovascular risk. But this brings me to Carlo, who has raised his hand, because Carlo is not only a top scientist, but is also a jogger. He went for marathons. So this is something we have in common. Carlo, please ask your question.
Hi, Göran. It's very nice to see you again after many years. Running reminds me of running with Peter in New Orleans at one American Heart Association meeting, and I've run a few marathons with Gareth Fitzgerald, which also cemented our friendship and our scientific collaboration. But I meant to ask you a more scientific question, Göran. The search for the holy grail of an anti-inflammatory drug that would be useful for preventing cardiovascular complications and have an ideal safety profile reminds me of the search for the holy grail in the antithrombotic field, having antithrombotic drugs that prevent cardiovascular events and yet do not interfere with hemostasis and do not cause bleeding. And we haven't been successful in finding one. And I wonder what is the situation in the anti-inflammatory drug field in terms of having the adequate basic knowledge of what is important in physiological inflammatory reactions and what is important and therefore should be targeted in terms of pathophysiological inflammatory reactions that contribute to cardiovascular events. Because unless we have this basic knowledge, it will be hard to have an ideal anti-inflammatory drug to be used in cardiology.
Yes, good point. And you, of course, have the perspective from everything that you developed and pioneered in the thrombosis field. Well, we saw with the CANTOS trial an important proof of concept with anti-interleukin-1 beta blockade, reducing secondary events. So the strategy works. Then, and Peter knows more about this because he was intensely involved in that study. But from my perspective, it's a proof of concept. It has obviously a powerful drug such as canakinumab has some side effects, not in a high frequency, but serious enough so that the regulatory agencies and clinicians hesitate to propose it on a broader scale. It has taught us, and also the colchicine trial, that the pathway going over interleukin-1 is a pro-atherosclerotic one that we can benefit from inhibiting. So that's an important piece of information. The inflammasome activation that leads to interleukin-1 production points to the macrophage. I would expect that now that we learn a lot about immunometabolism and metabolites affecting inflammatory activation, there might be metabolites that we can mimic in small molecules, which could be used for prevention. And then one will have to see which have the better profile when it comes to effects and side effects. So there's going to be a long chase for that. Let's hope. I'm optimistic with the progress that's been made, that is being made, but we're not there yet for a large scale primary or even secondary prevention on a broad group of individuals, as I see it. Perhaps Peter can add to this.
Thank you.
Right. Well, I think one can go upstream or downstream of interleukin-1 beta to the inflammasome, which, although it's proximal, there are a number of different isoforms of the inflammasome. So perhaps by inhibiting one, we would leave enough limbs of inflammasome signaling to preserve host defenses. And then going downstream of IL-1 beta to IL-6. So as most people know, we did a phase 2 study with a anti-IL-6 antibody, ziltivekimab, in patients with chronic renal disease that caused really profound reductions in C-reactive protein, over 90% at the highest dose tested. And so that was the prelude to a phase 3 trial, which is enrolling now, called ZEUS, which is allocating in a randomized fashion ziltivekimab to patients with stage 3 to 5 chronic kidney disease. And the hope there is that we will leave IL-1 beta's host defense properties intact while we neutralize interleukin-6, for which we have extremely strong human genetic evidence for causality in human atherosclerosis. So, it's going to take many shots on goal. The methotrexate study that Paul Ridker initiated and conducted was impeccably done, and methotrexate in low doses weekly has revolutionized the treatment of rheumatoid arthritis, but it was a complete null in cardiovascular. And we're very intrigued by the colchicine results. Again, colchicine is something we may wish to avoid in patients with renal disease, but I think that colchicine certainly provides us with a tool which we can use today in patients in whom we have very strong indication that inflammation is contributing to risk or recurrent events. I don't think that colchicine is absolutely free of infectious complications. If you look at the pneumonia signal in Colcott, it's there. So we need to have much more investigation on the safety side for any anti-inflammatory, to Carlos' point. But I share your optimism, Göran. And I would say the reason we don't have canakinumab isn't because the regulatory agency would not give an indication for the entry criteria for the trial. But the sponsor, with the exploratory analyses that we did, showing a dramatic decrease in cancer deaths, went off in another direction with that drug.
Thank you for your comprehensive answers. And I think here we have the first important message for our young colleagues. Please jog, go for marathons. This is how you can start becoming a top scientist in the study of atherosclerosis. Now, we have a question from Peter Lanzer. Peter, do you want to ask your question personally? I rate your question, but you can ask it, please.
Yes, thank you for the opportunity. I am one of the proponents suggesting that the medial sclerosis is not the type of atherosclerosis, but a different type of disease. I don't know if you agree with that assessment, but we see a lot of patients, particularly with peripheral artery disease, which show no signs of intimal disease except of myointimal hyperplasia. You don't see any plaques typical for atherosclerosis in these patients. And in severe cases, these patients even go to amputation without the typical symptoms of peripheral artery disease as of claudication. And so this myointimal hyperplasia seem to be a pacemaker of occlusion of the small arteries, but we, as far as I know, we have no clue what the cellular background of this severe myointimal hyperplasia could be. I wonder if you have any suggestions as of maybe possibly chronic inflammatory response to some medial disease could be the answer.
I don't think there's been enough work on medial sclerosis and medial inflammation. So I'm glad that you're identifying that problem and looking into it. There are some inflammatory or autoimmune conditions when you have an attack on the media, destruction of elastin lamellae and so forth. So it's worth looking at that literature, which is getting a bit old now, to see the patterns there and to what extent they are comparable to what you're observing. But I haven't worked on it myself, so I cannot really provide much more help there.
So I think that's an extremely important question. And in the limiting case, in the periphery, it's the Muckeberg sclerosis, right? Which is more common in diabetic patients, and where you really get railroad tract calcification, it's medial disease. And then, of course, medial inflammation and destruction is the hallmark of aneurysm formation, particularly AAAs, abdominal aortic aneurysms. And also, there's very strong evidence from George Stelides, for example, that inflammatory changes are important in thoracic dissection and aneurysms as well. So I think that the media definitely is a layer that could use more attention.
Thank you.
Thank you, Peter. There's also a question from Eloisa Arbustini. Eloisa, do you want to ask your questions directly?
Thank you. Thank you.
Elisa, hi.
Yeah, okay. You hear?
Yes, you can show your image if you want.
No, it was just, yes, thank you, Filippo.
It's more interactive.
Okay, thank you very much. Now, my question is, would like to address your opinion. You foresee future development of functional imaging for diagnosing in vivo in patients plaque inflammation, because you know, pathology studies are one shot, especially in humans. But we really need more developments of functional imaging in vivo in order to implement, plans for treatment, plans for probably reclassify atherosclerotic lesions in humans. So, what is your opinion about this? Do you need more research development? Do we need what is? I can't imagine how, with such an impressive implementation in cancer development in functional imaging, we are not having a parallel implementation in cardiovascular functional imaging.
No, that's true. And if you look back, it's an interesting question. If you look back a couple of decades, we were expecting a lot to happen in functional imaging. But the challenges turned out to be bigger than we had thought. Issues about penetration of labeled antibodies, for instance. So in essence, what's mainly used is still fluorodeoxyglucose in PET, and so working on using the Warburg effect, and we would have expected much more. But what we've seen instead has been a remarkable development in anatomical imaging. We get a resolution to an extent that we would not have expected 20 years ago. So we can learn much more about plaque composition from anatomical imaging with CT and MRI. And so it has not been a stop in progress, but it took a slightly different route. I would expect that we will get to better markers to be used in functional imaging. But you're absolutely right that it didn't move as fast as we had expected.
Thank you, Göran. Peter, I'm sure you have other questions for Göran. Please.
Well, just with respect to the functional imaging, I agree completely with Göran that using artificial intelligence and machine learning and the incredible power of contemporary coronary computed tomographic angiography, that we're going to be getting much closer to understanding more than just stenosis or the encroachment on the lumen, which was our traditional focus. And I think hats off to Valentin Fuster, because in studies like the PESA study, which we featured several of his recent papers in the European Heart Journal, he's doing pan imaging, including fluorodeoxyglucose imaging of the peripheral arteries and as well as central arteries. And we're going to be learning a lot from that. There's also the fluoride imaging, which is come from Edinburgh as well. So there are some molecular imaging technologies which are coming of age. But I agree with Göran. I think that ML and AI analyses of contemporary CTA are going to be a clinical tool that we can use in practice. Really, today we can do it for CT FFR.
Thank you.
I have two final questions for Göran. The first is back to the Nobel Prize. I mean, atherosclerosis remains the killer number one. In Europe, 20% of men die of ischemic heart disease, and 20% of women die of ischemic heart disease. For a woman, the probability of dying of ischemic heart disease is 10 times higher the probability of dying of breast cancer. So definitely atherosclerosis is important. Now back to the Nobel Prize. Is atherosclerosis so important? What do you see in your crystal ball? Any chance for the Nobel Prize on atherosclerosis?
I should not speculate on that. I can just say that the Nobel Committee looks for major discovery, ideally paradigm-shifting discoveries. So the mere volume of disease is not an important criterion to put in there, but with the progress we see in our field, it has a fair chance. But that's all I would say.
Thank you, Göran. And then my last question, and Peter, if you have additional questions, of course, we are very welcome. My final question is a question I ask frequently at the end of our dialogues. What are your suggestions for the future of EHJ dialogues? What can we improve?
Well, I think you're doing a great job already, and it makes the journal and the context between the journal and its readership so much more personal, and that's another dimension. I personally, I would want to hear more about translation from bench to bedside, perhaps also back, but it has challenges of its own, and there are some success stories that are worth describing and telling about. So I would love to hear more about that.
Well, thank you for your suggestion. I am open, of course, to more specific suggestions in this regard. Peter, you have a final question or final remark?
You know, I think it's been very nice that we have actually had participation of the audience, but most of the people who've asked questions are sitting in the front of the room. And it would be wonderful if we were able to stimulate some of the younger readers of European Heart Journal to participate in these. So we might talk about, when we meet in Rome, Filippo, if we have a board meeting, maybe we can think of strategies in which we can formally encourage the younger generation who will replace us and excel to participate in these dialogues more actively rather than passively. So I think that would be a goal that we can set for ourselves. And I think that cardiovascular research actually pairs a senior investigator with a more fledgling investigator. And I think that makes for a very nice flavor. So we should think of ways to engage you young people who are going to replace us and carry the ball forward in a more active way.
Thank you, Peter. Another excellent suggestion. So we'll work on this during our next editorial board meeting, but it's a very stimulating suggestion. So let's work on it. Well, this concludes our dialogue. I wish to thank Göran and Peter for really this interesting, brilliant participation to our dialogue. Thank you for spending your time with us, and really, I think all our colleagues in the room, because we are all in a room, it's a virtual room, but we are in a room. I'm sure that all enjoyed this atherosclerosis narrated by two giants like Göran and Peter. And let me close announcing our next dialogue. Next dialogue will be on December 29th at 17 Central European Time. And will be a very special dialogue, a different format. So please come and join us for the next dialogue on December 29th. Thank you very much. Bye-bye.
Thanks a lot. Thanks all of you. And thanks, Filippo, for organizing this.
And happy Thanksgiving.
Happy Thanksgiving, sure.
Thank you everyone for joining. We'll just wait for everyone to sign off. Quick reminder once again that our next dialogue is on the last Thursday of December, 29th of December at 5 CET. Thank you and have a lovely day.